Okay, so let's try the next coding exercise. So open the leetcode.com and go to the problems tab, and in the search question, search in order and hit enter. So we have the question number 94, binary tree in order traversal. So which come under the easy category. So let's click on it. So let's read the question. So binary tree in order traversal, given the root of the binary tree. So we have the root is given, that is the top node of the tree is given. Return the in order traversal of its nodes. So traversal means we have to traverse through the tree, and we have to print all the nodes. So in the tree we have the left node, we have the right node. So the how the tree look like, so the tree look like this only, like root number 15. Then we have maybe some another root on the left hand side, maybe there are some another root on the right hand side, right? So this looks like a tree. So we have some left node, some right node, right? And okay, so to traverse the tree, so there are basically three methods: in order, pre-order, and the post order. So this question is related to the in order traversal. So what is in order traversal? So in the in order traversal, what in order means, we have to go inside, like in order, right? So how I am going to remember this terminology, like in order, we have to print first left node, then root node, then right node. So in order means we have to go inside. We have to go inside. So it means first left, then root, and then what is being left, then right is left. Right, okay. So the same thing we have to do in this question. So let me remove this. So this is the in order traversal. So in the in order traversal, we have to print first the left node, then the root, then the right node. So for this question, so how this question will give the output? So we have to start from the left. So this is the left, this is the left part, this is the right part, right? So first all these nodes will be printed, then this nodes, then the root will be printed, and then the right. Now we have this subtree. So for this subtree, so this is the left and this is the right. So first 4 will be printed. So 4, so 4, then 10. All right, so 4, right, 4, then 10, then 12, okay, then 15, then 18, 22, 24. So this is the sequence. So we need to print this sequence. So where we need to print, we need to print in some array, or you can say a list. So, right. So how we are going to traverse, how you are going to print in the in order traversal. So we have to return some output, and output is in the form of a list, right? So we need some output array, right? Because we need some output. Fine. So how you are going to traverse, because only the root is given. So only the root is given. So only the root number 15 is given. But we don't need to print first root number 15. First we need to print root number 5. So there are two approaches. One is the recursive approach, one is the iterative approach. So we will try both the approaches. So first is the recursive approach, which is very easy approach. Even the iterative is also very easy, but let's look at the recursive approach. So in the recursive approach, what we will do, root number 15 will said its left hand side, give me your output. That's it. And root number 15 said its right hand side, that give me the output. That's it. And if whatever the output it will give, it will add after, let's suppose it gives some output. After that, 15 will be appended. Then whatever the output this side will be given, then it will be appended after that. So it will be appended after that. Okay, so we don't need to worry about anything. Everything will be uh, by handled by the recursion only. So as an example, So I think I gave you that beautiful example in my earlier video. So let's suppose there are 10 people in a row, right? And if I told you, can you count the number of people in a row? So one approach is you will run some loop and increment a counter variable, right? But if I told if I told you like you don't need to run a loop, so do without like running a loop. So how you are going to do that? So the other way is the recursion. So what we will do? So the person standing at the position number one. So the person standing at the position number one will inform to the person standing at the position number two, can you give me the count of the people standing behind you? So let's suppose, right? If whatever the output, the two will be written, one is going to add just plus one. And the two will set the same because two also don't know the anything. So two will set the same thing to the people standing at number three. Can you give me the count of the people including you and behind you? So whatever the three will return, the two will just add plus one. All right. So this sequence will go on at the last, at the like the person who's standing at the at position number 10. All right. So that person will look as at is behind, and there is no one standing behind. So person number 10 will return only a one output, that is only one to the nine. So this is called a recursion. So we need to do the recursion. So let's try to implement that. Okay, so we need some output array. Okay, and we need to follow the recursion. So in the recursion, what I said. So let's try one function first. So let's try one function def in order. Okay. Okay. So we have to call this function, and this function will perform the recursion. So self dot in order, and it is going to accept the root and our output. Okay, and whatever the output it will give, it will return, we will just return the output. Okay, so we will write our main logic here. So it is also going to like accept root and the output. Fine. So let's see. So if we have the root, because there could be some conditions like when there is no root might not be given. So let's suppose if there is a root, if there is a root, then what we have to do? If there is a root, we have to call our function on this subtree, right? So if there is a root, if there is a root, if there is a root, then what we have to do? We have to call our function. It means self dot in order. We have to call our same function on the left hand side of the root. So root dot left. Okay, right? Root dot left, and we have to uh, even we don't need to write the output here. Okay, now so we are calling, we have called our left hand side function, so it will do its logic. All right, after that, so it will, let's suppose it is returning something, it is returning something, so that something will be in the output. So we are just assuming it will return something, because the recursion will run on the hypothesis only. We will assume the left will return something, so left will return something. After that, we have to append 15 on the output of whatever the it will going to return. So what we have to do? We have to output dot append, we have to not 15, we have to append the root, whatever the root. Then what next? Then we have to call the function, call our function on the right hand side. Then we have to call our function self dot in order root dot right. That's it. So let's try to run it. In order require one position argument. Okay, so we have to pass the, because it is expecting two arguments. Okay, let's try to run it. So type error string return plus is not a valid value for the expected return type list of integer. Okay, so here we have to return the root dot value because we don't need to return the root, we have to return its value. So let's try to run it. So now our solution has been accepted. So let's try to submit it. So our solution has been accepted. So using the recursion, so like you see, it's very easy. In the recursion, what we said, the root will set to its left hand side. Can you give me your output? So left, whatever the root is just calling the same function. Can you give me the output? So it will give some output. All right. Then root said, okay, you give me the output. Now I am going to append. Right, and after that root will said, okay, I am calling the left hand side of the tree. So in the first instance 15 is going to call its left hand side, right? So self dot in order root dot left will be called, so function will go here, right? So now the root will become 10, right? Now the root will become 10. So now the again, so if root, yes, we have the root. Now root is calling its left hand side, so 4. So here will be 4. So it is going to call again. So now the root will become 4. Now 4 is again going to call its left hand side, but there is nothing on the left hand side. There is nothing on the left hand side. So it is like if there is nothing on the left hand side, it just return. It just return means like this function finish. If it just return means this particular function is finished. Now it is going to because it is like calling this function, this tree when the root is 4 and there is a nothing, and there is a nothing, uh, the, uh, 1 second. So there is nothing on the left hand side of the 4. So now it is going to return, and it did not return anything. So what we have to do, we have to in the output we have to append root dot value. So root is 4, so we are appending the root dot value which is 4. So in the same sequence we are following our recursion. Okay, so using the recursion it's very easy, but like let's try to implement the iterative approach. So uh, we see the recursion, so to implement into the iterative approach, the other solution is the using the stack. Okay, so let me remove this. The recursion is done. Now we have to implement the using the stack, using the iterative approach, and within the iterative approach, what we will do, we will use the stack. So we will take our output array because we need output array. So we are taking the output array. Okay, because we need to return some output. Okay, now what we have to do, because we are given only the right pointer, on not sorry, we have only given the root pointer. 15 is given only, but in the first instance we don't have to print the 15. So what we will do, we will store this 15 in at somewhere. So we have to store somewhere. So we will take some stack. So we are storing 15 at somewhere. So we store the 15. Now we will check. So so like we will like so first we will check, okay, if there, because let's suppose if the tree is empty, then we don't need to store anything. So before storing anything into the stack, we will check if there is a root. If there is a root, yes, there is a root, then we are going to store that particular element into our stack, because we don't need to print, we don't need to append our output. So that's why we are going to store. Now we will move further. So where we are going to move, because first we have in the in order traversal, we have to print the left hand side. So then what we will do, we will make root to this node. Then root will become root is equal to root dot next. So now our 10 will become root. So we will see if it is current, if the root exists, yes, the root exists. So we are going to store our 10 in the in our stack. Now, now, so now what root will said? Okay, now the root will become 4. So root is equal to root dot next. Now the root will become 4. Okay. So we will check. Okay, if there is a root, yes, there is a root. So we are going to store our root element or the current element into the stack. Now it will go further. It will go further. It will check where it will find null. So now the root will become null. So we will check if there is a root. No, there is no root. All right. If there is no root, so we have to stop some process. Okay, our pointer will become null. Then what we will do? We will start popping the elements from our stack. So now we are going to pop our elements from the stack, right? So we pop our element from the stack. So we pop the element from stack and append into the output. So now 4 will become here and we will pop element from here. All right. So we pop from here. Okay. Then we are going to check the right element of the 4. So we are going to check the right element 4. So there is nothing on the right. There is nothing on the right. Okay, which is like perfectly fine. Then we are going to pop the next element of the stack. So now here, so the 10 will be pop and 10 will come here. 10 will become here. So we popped from here. Okay, now we are checking the right hand side of the uh, because when we are popping, so as soon as we pop, when we are just inserting, at the time of inserting we are making root is equal to root dot left, but when we popping we are making root is equal to root dot right. So now we have the right element, root is equal to root dot right. So 12 become 12 become root, right? So now we will check, okay, if there is a root, yes, there is a root, so we are going to insert into our stack. So if there is a root, okay, now it will go, root will check its left hand side. So there is nothing on the left hand side. We are going to pop. So we are going to pop. So now 12 is going to pop. All right. So now 12 we check its right hand side. If there is nothing, if there is a nothing, then the 15 will be pop. So 15 will be pop. So first 12 will be pop, then 15 will be pop. Okay. So 15 will check it's like a right hand side. So all this way now. So by using the stack, so we can easily implement the solution. So let's try to implement that. Okay, so let's try to implement that. So what we have to do is we need to run some loop while true, and we need the stack as well. So we need the stack. We need the current pointer. So which is root, or you can say while root, whatever you want, right? So while true. So first we will check if current. All right, so if current, so or even you don't need to take the current pointer. I don't think we need to take the current pointer. So we can just take a root only. So while true. So while true. So we will check if there is a if root, yes, if root. So if there is a root, but then what we have to do? We have to push this into stack. So what we will do, stack dot append root. So 15 will become, so if root, then 15 will become here. Okay. Now what we will have to, now we have to go into the left hand side because we know it's the in-order traversal. So first left is going to, now we have to do root is equal to root dot left. So now 10 will become root. Right, 10 will become root. So it is going again because it is a while loop, it is going again above. If root, yes, if root, 10 is a root, then again we are going to append. And now root will become root dot left. So 4 will become root. All right. So now again the while loop will be run. So if a root, yes, if there is a root, then we are going to append. Then we are going to append. All right. And the root is become root dot left. So root become root dot left. So at the left there is a nothing. At the left there is a nothing. All right. So we have appended till now 4, 10, 15. Now what we have to do? So if root, then it is fine. But if not root, all right, then what we have to do? So L if not root, If not root, then we have to start popping. But before popping, it could be the thing that the stack could be empty, right? So we can't put just else, and we can't do like stack dot pop. We have to do this only. So let's suppose you just put, okay, if there is a no root, then we will start popping. Okay, we have to pop 4. So we pop 4. So our element will be, so let's suppose this is the temp element, or you can say root element. Root is equal to stack dot pop, and we need to output dot append root, because we need to pop our fourth element. We need to pop our fourth element, and we need to append into the output, which is perfectly fine. Then as soon as we pop, we make our root is equal to root dot write. Root is equal to root dot write. So root dot write means uh, this. So now it's again null. So it's, if it's again null, then we are going to check if root. No, it's not root. So else, then stat dot pop. Now the 10 is going to pop. So now the 10 is going to pop, and 10 is going to append. Okay. Now we will check. Root is equal to root dot write. So root is equal to root dot write. So now 12 will become root. Now we will check if true, if root, yes, if root, then we are going to append 12 here. And root is equal to root dot left. So root dot left means uh, left of 12, there is nothing, right? So it's become empty. It is become empty. Then we will check if root, no, it's not root, then we are going to pop. So we are going to pop 12. So we are going to pop 12, right? And we will make a root is equal to root dot right. Then we are checking root is equal, if is there anything on the right, so root will become null. So we'll check if root, no, it's not root, then we are going to again pop. So now 15 is also popping. 15 is also pop. Okay. Now we will check if root, yes, there is a root, then what we have to do? We have to append, if there is a root. So 15 is a root. So we are going to, so 12 is equal to root, is equal to root dot right. Okay, so there is nothing. Then if root, so okay, then we are going to pop if root. Then we are going to pop 15. Then we have to append. So in the same way, now like we have to do that, but like there should be some condition when the stack should be empty. So before popping, we have to check if stack. If there is something in the stack, then only we are going to do something. Otherwise, what we have to do is, otherwise we will break. Right? Our solution will be done. So return output. Okay, so let's try to run it. Okay, so here we have to like append the value, node the node. So our solution has been accepted. So let's try to submit it. So our solution has been like accepted as well. So that we did. So we are not we in this solution we have not used any kind of like a recursion. All right, but we use the iterative approach. Iterative means we have run some loop, and in this case we run some while loop, but we use some extra space. So that is called a stack. So this is very easy question, and similar to that, there is a pre-order and the post-order traversal as well, and everything is going to just remain same. Just the when we are going to print the root node and when we are going to call the left hander, just that sequence is different. Right. So in the coming videos, we are going to cover the pre-order and the post-order traversal as well. So thank you. You can also try that question.